Same region replication. 1. Same region replication SRR supports automatic and asynchronous replication of new S3 objects to a destination bucket within the same AWS region. So we have seen cross region, which is between two regions. This is between same region. Same region replication creates another copy of S3 objects within the same region, maintaining the same redundancy as the destination storage class. This allows automatic aggregation of logs from different S3 buckets for in-region processing or configuring live replication between test and development environments. Same region replication aids in addressing data sovereignty and compliance requirements by keeping a copy of your objects in the same AWS region as the original. So we will see now Amazon S3 static websites part 1. Static website hosting. Amazon S3 can host static websites which contain static content. AWS console, easy configuration for static website hosting on Amazon S3 from the AWS management console. Website setup. Static website hosting on S3 requires bucket configuration and content upload. Bucket configuration. Bucket configuration for static website hosting involves enabling website hosting, setting up the right permissions, and adding an index document. Advanced configurations. Configurations for redirects, logging, and custom error documents based on website requirements. Amazon S3 static websites part 2. AWS SDKs. Website configurations can be managed programmatically using AWS SDKs in absence of AWS management console. So you can automate using SDKs as well. Naming convention. So avoidance of dots in bucket names except for static website hosting for best compatibility. Certificate validation. Dots in non-static website bucket names restrict virtual host style addressing over HTTPS. Virtual hosting. Security certificates for virtual hosting do not support dots in bucket names. So path style URLs. So positioning. Path style URLs position the bucket name after the global or region specific endpoint as in the format like this: HTTPS, region specific endpoint, bucket, and object name. So this is path style URLs, which wherein after the endpoint you have the bucket name and the object. So in this model, the bucket always exists as a subdomain of s3.amazonaws.com, and DNS resolution always leads to a subdomain of s3.amazonaws.com. So it will be something like this, and then followed by your bucket name and then the object name and the file name. So path style URLs allow multiple accounts, potentially from different companies or owners, to map to the single subdomain, which is s3.amazonaws.com. If a customized URL is needed, one should always consider virtual hosted URLs. So this is path style, and there is a virtual hosted URLs. So virtual hosted style URLs. Virtual hosting, serving multiple websites from a single server. Host name usage. So use of bucket name in the domain name for differentiation. So in this case, bucket name comes a part of the like HTTPS and the region name. So customizable URL. URL customization by naming the bucket after a registered domain. Example customized URL. So example of a customized URL, for example, it could be for a course or something. And root directory publishing. So this option is there. Virtual hosting allows publishing to buckets root directory. SSL with virtual hosting. SSL wildcard certificates match buckets without dots in their names. And dot usage in bucket names. Either avoid using dots or use HTTP for certificate validation. Now we'll see S3 strong data consistency model. Amazon S3 now offers strong read after write consistency for all storage requests without affecting performance, availability, or regional isolation of applications, and with no additional cost. Following a successful write of a new object or an overwrite of an existing one, Any subsequent read request instantly gets the latest version of the object. Amazon S3 also provides strong consistency for list operations, meaning that any changes are immediately reflected in a list of objects in a bucket after a write. This enhancement is crucial as previously Amazon S3 was strongly consistent for new objects and eventually consistent for modified or recently queried objects. So with the rise in use of high process analytics engines, applications and users require immediate access to upload data. No additional charges, so there is no charge for this enhancement, and it applies to all get, put, list and head request, as well as access control list, object tags and other metadata. This feature is available for various request handling. This feature is available for various requests including get, put, list, head, access control list, object tags and other metadata. And bucket operations. For bucket operations such as reading a bucket policy or metadata, the consistency model remains eventually consistent. So strong data consistency for data, but for reading bucket policy or metadata, it's only eventually consistent. So versioning in Amazon S3. Versioning is a system of maintaining multiple variants of an object within the same Amazon S3 bucket, allowing you to preserve, retrieve and restore every version of every object stored. With versioning, you can effectively recover from unintended user actions and application failures. If Amazon S3 receives multiple write requests for the same object at the same time, versioning is enabled, all the object write requests will be stored. When you enable versioning for a bucket, Amazon S3 automatically generates a unique version ID for the object being stored. Within a single bucket, you can have two objects with the same key but different version IDs, such as, for example, if you have a JPEG image like dolphins.jpg, then you can have version 111 and same image with different version ID. So if you delete an object in a version enabled bucket, Amazon S3 does not permanently remove it, but instead it insert a delete marker which becomes the current object version. You can always restore the previous version. If you overwrite an object, it results in a new object version in the bucket, allowing you to restore to previous version if needed. Put operations. The put request operation is used to add an object to a bucket. To add an object, you must have write permissions on the relevant bucket. Amazon S3 ensures complete object integrity by never adding partial objects. If you receive a success response, the entire object has been stored durably. If an object already exists in the bucket, the new object will override the existing one. While Amazon S3 orders all of the requests it receives, if two requests are sent almost simultaneously, they might be received in different order than they were sent. The last received request is the one stored, meaning that if multiple parties are writing to the same object simultaneously, only the last write is preserved, even though all parties may receive a success response. As Amazon S3 is a distributed system, it might take some time for one part of the system to communicate that another part has received an object update. Okay, next is multi-part upload API. You can upload or copy objects of up to 5 GB in size in a single put operation. For objects up to 5 TB in size, you are required to use the multi-part upload API. So 5 GB of single file, but if it is more than 5 GB, you have to use this particular multi-part upload API. So basically it will split the file into multi-part, then upload it, and then it will join or merge at the server level or the cloud level. The multi-part upload API enables you to upload a single object as set of parts, each being contiguous portion of the object's data, which can be uploaded independently and in any order. Multi-part upload breaks a large object into smaller parts, improving throughput and allowing for retransmission of only the failed parts instead of the entire object. After all parts of your objects are uploaded, Amazon S3 assembles these pieces and creates the object. When your object size reaches 100 MB, it is generally recommended to use multi-part upload instead of uploading the object in a single operation. Using multi-part upload provides advantages like improved throughput, quick recovery from network issues, and the ability to pause and resume uploads, starting an upload before knowing the final object size. Okay, object lifecycle management for multi-part upload. In the case of multi-part uploads, Amazon S3 retains all parts on the server until the upload is either completed or discontinued. To avoid unnecessary storage cost due to incomplete uploads, it is important to either complete or discontinue an upload. Lifecycle rules can be used to automatically clean up incomplete multi-part uploads. An Amazon S3 lifecycle configuration is an XML file comprising a set of rules with the predefined actions that Amazon S3 is configured to perform on objects throughout their lifetime. As a best practice, it is advised to set up a lifecycle rule using the abort incomplete multi-part upload action to minimize storage cost. It is recommended to enable the function to clean incomplete multi-part uploads in the lifecycle settings, even if there is uncertainty about performing multi-part uploads. Application default. So some application might default to multi-part uploads when uploading files above a certain size. Failed or incomplete uploads in such scenarios can lead to increased storage cost. Okay, get operations. The get operation can be used to retrieve an entire object or parts of an object directly from Amazon S3. If there is a need to retrieve the object in parts, the range HTTP header can be used in a GET request. This enables the retrieval of a specific range of bytes from an object stored in Amazon S3, allowing other parts of the object to be fetched whenever it is convenient or the application is ready. And this resumable download can be beneficial in situations where only portions of data are needed, when network connectivity is poor, or if the application must process only subset of the object data. Okay, delete operation in Amazon S3. A delete operation in Amazon S3 can be used to delete either a single object or multiple objects in a single delete request with different possible outcomes depending on whether the bucket is version enabled or not. In a bucket that is not version enabled, an object can be permanently deleted by specifying the object's key name in the delete request. This action permanently removes the object from the bucket, rendering it unrecoverable. In a bucket that is version enabled, the delete operation can either permanently delete an object or cause Amazon S3 to create a delete marker for the object, thus making the object recoverable. Individual version of an object can be permanently deleted in a versioning enabled bucket by invoking a delete request with both the object's key and version ID. To entirely remove the object from the bucket, each individual version must be deleted. If a delete request in a versioning enabled bucket specify only the object's key name, Amazon S3 insert a delete marker which becomes the current version of the object. Attempting to retrieve an object that has delete marker results in a 404 not found error. However, the object can be recovered by removing the delete marker from the current version of the object, thus making the object available for retrieval. Block public access in AWS S3. AWS has introduced the S3 block public access feature as a measure to help users avoid unintentional data exposure. The S3 block public access feature allows users to manage the public access of their Amazon S3 resources at both the account level and the bucket level, thereby ensuring that their data does not become publicly available by mistake. In the case of a new bucket created, the feature to block all public access is enabled by default. If users desire to grant public access to any of the resources managed by the block public access feature, they will need to make adjustment to their block public access configuration. Amazon S3 block public access settings. First, block all public access. Second, block public access granted through new ACLs. Third, block public access granted through any ACLs. So this is new ACLs and block any ACLs, not new, any ACLs. Block public access granted through new public bucket policies. And last, block public and cross account access granted through any public bucket policies. Okay, first we'll see block all public access. There is an option that allows users to ensure that a bucket will never permit public access. This can be enabled with a single click. Once enabled, this option supersedes any configured access control list, ACLs and bucket policies, thereby overriding any permissions that would typically grant public access. This option to block public access is enabled by default for any new buckets that users create. If users want to permit public access to their buckets or objects, they will need to disable this blocking option. Block public access granted through new ACLs. This feature prevents the creation of any new access control list ACL that would grant public access permissions either to a bucket or object. The enabling of this option does not affect any existing ACLs or policies. Therefore, any current ACLs or policies granting public access will remain unaltered, and public access to the corresponding resources will stay intact. Once this option is enabled, it is advisable to review all existing ACLs to evaluate current public access permissions and to assess whether these permissions should be retained. It is worth noting that if there are existing bucket policies or ACLs that grant public access to buckets and objects, these resources will continue to be publicly accessible even with this option enabled. If the goal is to block all public access to bucket and objects, the block all public access option should be chosen. Okay, now block public access through ACLs, through any ACLs. So this option predominantly influences how you evaluate access control list ACL public permissions. When activated, it disregards any existing ACLs that grant public access to buckets and objects. While it does not modify the existing ACLs themselves, resources with public ACLs will no longer be publicly accessible. Interestingly, this option does not prevent the creation of new ACL that grant public access. While you can still establish them, these ACL will not take effect, resulting in the bucket or object not becoming publicly accessible. Once this option is enabled, it is advisable to review and remove any public ACLs to avoid potential failure errors. If this option is later disabled, any existing public ACLs will no longer be ignored. It is important to remember that even with this option activated, if there are bucket policies granting public access to buckets and objects, these resources will remain publicly accessible. So if you wish to block all public access to buckets and objects, it is recommended to choose the block all public access option. Okay, now block public access granted through new public bucket policies. Okay, this setting only obstructs the creation of new bucket policies that would grant public access. It does not affect any pre-existing bucket policies. If any bucket policies are currently configured to grant public access, those buckets or objects will continue to be publicly accessible. For effective application, this setting should be implemented at the AWS account level. Since a bucket policy can allow users to alter a bucket's block public access settings, users with authority to change a bucket policies could introduce a policy that lets them disable the block public access settings for the bucket. If this setting is enabled for the entire account rather than a specific bucket, Amazon S3 blocks public access even if a user modifies the bucket policy to disable this setting. Bear in mind that with this option enabled, if there are any existing bucket policies or ACLs granting public access to buckets or objects, those resources will still be publicly accessible. To block all public access to buckets and objects, opt for the first option, block all public access option. Okay, block public and cross account access. So this option only influences how you assess bucket policy permission. When activated, it disregards any buckets or objects having public permissions granted via bucket policies. On enabling this setting, access to bucket with a public policy is restricted to only AWS services and authorized users within the bucket owner's account. This setting blocks all cross-account access to a bucket with a public policy except by AWS services, while still allowing users within the same account to manage the bucket. It does not modify existing bucket policies, but it does ignore any existing bucket policies that grant public access, thereby blocking public access and any cross-account access configurations. Keep in mind that with this option enabled, if you have any ACLs granting public access to buckets and objects, they will remain publicly accessible. If you wish to block all public access to buckets and objects, then opt for the first option, block all public access option. And that's all. Thanks for watching.